Hello friends, I welcome you in lecture number 7 on logic. In this lecture, we will discuss some more questions on tautology, contradiction and contingency. In previous lecture, we have discussed the definitions of this tautology, contradiction and contingency, and we know that a compound proposition is a tautology if it is always true. Similarly, a compound proposition which is always false is called a contradiction, and contingency is that type of compound proposition which is neither a tautology nor a contradiction. So with this in mind, we try to answer this question on tautology which was asked in GTU Summer 2022 exam. Here we have to show that this conditional statement P and Q implies P or Q is a tautology, and we know that to prove that this compound proposition is a tautology, we can use truth table. We can prepare the truth table and then we will see the column corresponding to this implication, and if all the values in that column are having truth value true, then this becomes a tautology. Here I am having only two propositions P and Q, so I will have four possible combinations as we have discussed in earlier lectures, and we first require conjunction of P and Q and disjunction of P and Q, and after that we will require this conditional statement or implication. P and Q implies P or Q. So now I am writing all the possible combinations for P and Q. T, T, F, F, then T, F, T, F. For P and Q, it is true if both are having truth value true, otherwise it is false. So it is true in this case only, and here it is going to be false. P or Q is false if both are having truth value false, otherwise it is true. So if there is at least one truth value is T, then P or Q is true. Therefore here I will have T, and here both are false, therefore here I have false truth value. Then we have to write down the truth values for this implication. P and Q implies P or Q, and we know that this implication is false if P and Q is true and P or Q is false. So here P and Q is true and this is also true, therefore we have truth value T, and we know that whenever we have this type of conditional statement, so it is going to be false if P is true and Q is false. In all other cases it is having truth value T. That means if first proposition is false, then in that case this implication is always true. So now I have all the truth values for P and Q, that is first proposition are F, therefore this is having truth value T. Implication or conditional statement is false if first one is true and second one is false, but here we are not having that situation, that we are not having the case that P and Q is true and P or Q is false. Therefore we have all the truth values as T, and we can therefore say that this implication P and Q implies P or Q is always true because all the truth values are T in this column, and therefore we can say that this is going to be a tautology. P and Q implies P or Q is a tautology. So now we consider another question on tautology which was asked in GTU Summer 2022 exam. Here we have to prove that this compound proposition is a tautology, and we can see first one, this first statement is conjunction of two implications P to Q and Q to R, and here we have implication P to R, and here we have conjunction of P to Q and Q to R. And now I have three propositions in this compound proposition. So first I am writing these three propositions P, Q and R. After that, what I will require P to Q, then Q to R, and then this conjunction of P to Q and Q to R. So that I am writing first P to Q and Q to R. Then I will require P to R also, and after that we will be able to find out truth values for P to Q and Q to R, and this implies P to R. And now we have different situation. In previous examples which we have discussed up to this lecture, we were having only two propositions, and therefore we had only four possible combinations for the truth values of P and Q. Now we are having three propositions P, Q and R, and therefore we have 2 raised to 3, that is 8 possible combinations for the truth values of P, Q and R. So how to write down those possible combinations? So for that we can consider Cartesian product of this set TF 3 times. There are two possible truth values for P, Q and R. So for first we consider Cartesian product of these two. If I fix T as first element, then I have TT, TF, then I have FT and FF, and then I will take Cartesian product with TF. So again I consider first element as TT, so I will have TTT and then TTF. After that I consider first element as TF, second element possible is T and F, so TFT, TFF, then FTT and FTF, and finally we consider FF as first element, so FFT and FFF. So in all these possible combinations, this first one is for P, second is for Q and third is for R. So we can see for P, first 4 values are T, and after that 4 values are F. So we will write in this way. First we are writing for P. For P we have 4 truth values, first 4 truth values as T, and after that 4 values are having truth value F. So we write in this way. Similarly for Q we have second one, so we can see TT, then here we have FF. So for first 4 we have TT, then F and then F for possible combinations of Q. After that again we look here again I have TT and FF. So second positions are for Q, so here I write TT and then FF. These are the possible truth values for q. And for last one we can see we have t, then f, then again t, then f, t, f, t, f, alternately t, f, t, f. So we are writing for r as t, f, t, f, then t, f, and again t and f. So if you wish you can remember this. This is easy to remember. For p, first 4t, then first 4f. For q, first 2t, then ff, then tt, then ff. For r, alternately tf, tf, tf. So you don't have to do this Cartesian product every time. But if you don't want to remember this, then you can first write down the Cartesian product and then you can write down all possible combinations for truth values of p, q and r. So just a minute, let me remove this. For two propositions also you can write down using Cartesian product, which we have written as in previous examples we have written. Now we have to use the definition of implication. So we know that this p to q is false if p is true and q is false. So now we concentrate on p and q. If p is true and q is false, then only it is false. So here p is having truth value t and q is also t. Same thing for second possible combination. Here we can see p is true, q is false, therefore p to q is false. Similarly here p is true and q is false, therefore this is false. Now if p is false, then in that case we can directly write that p to q is true. So now in these four possible combinations of p, we have p as false, therefore p to q is true. Okay, remember p to q is false if p is true and q is false. In all other cases it is true. Similarly we write down this q to r. So here also q to r is false if q is true and r is false. So for first possibility q is true and r is true, therefore this is true. Here we can see q is true and r is false, therefore this is false. If first statement is false, then we can directly write down truth value for implication as t. Here this is true and this is also true. Here we have to write for q and r. So let me check again. Q and r is true. If q is true and r is false, so therefore this is correct. Then q is true and r is false, therefore this is false, that is also correct. Here we have q false, so we can directly write t here. After that q is true and r is true, therefore we have true here. Here q is true, r is false, therefore this is false, and because q is false here, we can write t here. And same thing we write for p to r first, then we will write this one. So for p to r, this is false if p is true and r is false. So here p is true, r is true, therefore we have truth value t. For second row, p is true and r is false, therefore this becomes false. For third row, p and r both are true, therefore we have true here for third row. Here p is true and r is false, therefore we have false here. And in the remaining cases p is false, so we can directly write truth value t here. So that is for p to r. Now we have to write conjunction of P to Q and Q to R, and because we have AND operator here, this is true if both of these are true. In all other cases it is false. So here both are true, therefore we have true here. Here we have F, therefore this is F. Here also both are F, so this is going to be F. And here both are true, therefore this is true. Here we have one F, therefore this is false. And here both are true, therefore this is true. And in the next step we have to find out this conditional statement, that is, this implies P to R. So now we are applying implication of these two. This implies P to R, and again we know that this is true if this statement is true and this statement is false. So now we check. In the first case both are true. Now if first statement in the implication is false, then we directly write true here. Now here this is true and this is true, therefore we write true here. Here first one is false, therefore this is true, and here both are true, therefore this is true. And now we can observe that all the values in the column corresponding to this proposition are having truth value true. Therefore we can say that this compound proposition is always true, and therefore it is a tautology. So I am not writing whole proposition, I am simply writing that given proposition or it is a tautology. And they ask this type of questions for 4 or 7 marks, and you can see it is easy to construct the truth table, but we have to be careful. Here all we have applied is we have applied this conjunction operator, and we have applied the definition of P to Q. Remember, this is very important definition. We remember in this way, this implication is false if first proposition is true and second proposition is false. In all other cases it is having truth value T. So whenever I have P as F, then this is going to be true. So in this way we can easily prove that given statement is a tautology or not. So this is all about this session. I hope you like it. Thanks for watching.